Hello and welcome everybody to a new video. You saw the title of this video. Today we're going to be talking a little bit about Ruby, a little bit about Rust, and a little bit about my experience with porting an app from Ruby to Rust. So I suppose I should start with a little bit of background really as to why I'm doing this. Also talk about what is Ruby, what is Rust, what are the differences, why do we care? So the background to this, Rust is kind of a new-ish language. I've been quite interested in a while. I wanted to try it out. I did the sort of tour of Rust type thing a while ago, and it's kind of fine. It's good, but for me, I find it really difficult to learn something if I don't have an actual project that I need to apply it to. So if I want to learn something like a new programming language or something like that, I usually need to have some sort of project, like an actual thing that I want to build, want to do with it, so that I can actually stick to it. Otherwise, I just get distracted and bored, and don't really pay attention to what I'm doing anymore, and then forget about it. So with that, I decided what would be a good project to do is to take an old piece of Ruby code that I had written a while ago and see if I could port it over to Rust. So one of the specific reasons why I chose this piece of code that I had written is because I think it's something that would lend itself quite well to Rust. So just this past December, during Advent of Code, which I do every year, if you've not seen my playlists, link in the description, you'll see I've got 2 playlists for the last 2 years of Advent of Code. I noticed in the subreddit that there was a lot of solutions being submitted for Rust, and some of them had extremely impressive performance. So with that in mind, I was thinking about like the performance it has on doing like, complex algorithms and stuff like that. And this particular piece of code we're going to look at today, which looks at the marching squares algorithm, is something that I thought Rust might be actually quite suited to doing. So with all that said, let's pull back a little bit and talk about what is Ruby, what is Rust, and what are the differences. So both Ruby and Rust are they're general purpose programming languages. So effectively you can write applications in them and they'll work more or less anywhere, like any operating system, Windows, Mac, Linux. And yeah, you can kind of do whatever you would like in them, build any kind of applications you want. But they are very, very different. So I'm not going to get into too much, like you could fill books with the differences between them. I'm not going to get into all their language features and stuff like that. What I'm going to do is I'm going to take just a couple of the differences between them, and I want to throw up some code here and show you, highlight where some of those differences are. One of the first things, which I can talk about kind of more abstractly before we look at any code, is one of the key differences between Ruby and Rust is basically the way your computer executes the code once it's written. Once it's written. So Ruby is what we would call an interpreted language, whereas Rust is a compiled language. So there's loads of different interpreted languages out there. Ruby is one. Python is another example of an interpreted language. Something like JavaScript as well is also an interpreted language. So effectively, what an interpreted language is you write your code, and then there's some application that's running. In the case of Ruby, there's the Ruby itself is running on your computer. So you effectively tell Ruby, this is my application. You point it at your script that you've written your code. Then the Ruby binary, the Ruby app that's running, literally reads your code, interprets what it is, and then executes what it's telling it to do. So you may have, if you know a bit more about programming, or if you've done some basic programming, there's this idea of like compiling your code, where say if it's a basic C application, which a lot of people may have written, as in it's one of the first languages you'd often get taught in like university or whatever. In that instance, you had to write your code and then you had to compile your code. So it basically takes the code, the symbols that you've written, it compiles it down to some sort of really basic thing that your computer can understand, and then your operating system can directly execute those instructions, and that's how it runs. So Ruby doesn't do that. Instead, Ruby has like a binary that's running that, is telling your computer what to do, but that binary is actually reading the Ruby code itself, figuring out what to do, and then telling it what to do. So there's kind of a level of abstraction above your operating system and that sort of stuff, which has its advantages and has its disadvantages. So it's never going to be as efficient as something that compiles directly down to like the bytecode that your computer understands. But it has other advantages. So one of the main advantages, which we'll get to in a little bit, is to do with like how quickly you can develop stuff in Ruby. Anyway, Rust. So Rust is like C, like I mentioned earlier. It's a compiled language. So you write your code, you give it to the Rust compiler and say, make this application for me, make this binary for me. The compiler effectively takes all that code, reduces it down to a really simple set of instructions that your operating system understands, and then it runs natively on your operating system. So it can get much closer to like the bare metal, as you might say. So it can run really, really efficiently. And there's also a load of optimizations that can be done to make it run super fast. But Rust then has other things that make it not as quick to develop on, not necessarily as quick to develop on. So there's often this kind of trade-off between like things like Ruby and Python, and then, other compiled languages like something like C, C++, Java, even C#, which they're a slightly different class again. Not going to get into that, but similar kind of ideas. It's like you're trading off performance basically for how easy it is going to be to develop on the platform. So, with that said, why did I originally choose Ruby for this kind of thing? For me, my background, I'm a professional software engineer, and I've been using Ruby for years, specifically Ruby on Rails for web application development. And this is one of the big selling points for Ruby, is especially for small companies that want to move really fast and develop things, you can prototype extremely fast in Ruby. Ruby on Rails then again puts that literally on Rails. It comes up with loads of really good out of the box kind of what's the word for it? Systems for things, basically like conventions for things, that's what I was looking for, where you can do things really quickly and it'll just do things convention over configuration. It does things automatically out of the box for you, so you don't have to think about them, which can let you move extremely fast. Rust, on the other hand, basically nothing out of the box. You have to write things from scratch, and that's some of the power of it. Rust is what we would call a systems programming language, so I'm not going to get into too much detail what that means, but effectively you can write things, you have a lot of freedom to write things how you want to write them, and you can be extremely performant with them. Okay, so that's a little bit of background. And yeah, the reason I wrote this originally in Ruby is because I think quite quickly in Ruby, and I find if I need to write something really scrappy just to get something to work, I'll jump into Ruby because it's fast and I can work on it really, really quickly. Same reason why I have done my advent of code in Ruby for years, because I think very quickly in it. I can write stuff really quickly, delete stuff, and just make changes quickly and not have to worry about like creating types and structs and all sorts of stuff. I can just throw things at it and it just kind of does what I want it to do. But it's far from performant for a lot of these things. So, I mean, it can be performant. It's not like when we're talking about performance, it's like, differences in milliseconds perhaps, or microseconds in milliseconds. Like, it's not going to make much of a difference if I'm just running a silly advent of code problem. So for me, the development efficiency of using Ruby usually outweighs using Rust or something else like that. So what should we talk about next? Okay, yeah, so some of the other differences then. We'll jump into the code now and have a look at some of like the structural differences between like a Rust application and a Ruby application, and what kind of choices I made. I'm kind of going to jump around a little bit here. I don't have a super clear plan about how I want to talk about this, but I can show you a few things anyway. So we talked about interpreted versus compiled. So one of the other big differences between Ruby and Rust is the type system. So you may have heard the idea of types before, especially if you studied any type of programming at like university level or that. And types are kind of they're simple enough concept. The idea is that I need to know the difference between things that are numbers and things that are letters, strings, characters. And then if it's numbers, I need to know, well, is it integer numbers 1, 2, 3, or could it be floats? Can I have decimals 0.5, 0.2, whatever, and we kind of know about these things. They're pretty simple. And some languages will have they will be what is called very strongly typed. So a strongly typed language, if you declare something as an integer, it's an integer and that's it. It can't store anything else in it. Then other languages go at a completely different approach where it doesn't matter what it is. You can declare things. You don't declare a type. Types are always just inferred based on the things that you put into them. And then you can change that as well in some languages. So if you have a variable and you've stored an integer in it, then later on in your code, you could just overwrite that with anything else. And the application doesn't care. Nothing really cares. It just figures out what it needs to do in the background and does it. And that is basically what Ruby can do. So if we look at my Ruby code here, which I'll just zoom in a little bit for you, this code, you'll see as you scan down through it, there's no types mentioned at all. There's no variable definitions as such. Variables are defined or initialized, but there's no definitions. I haven't told Ruby what any of these things are. It just has figured out what they are. So if we go down and have a look at some basic ones, like here, for example, there's this thing here, call count equals 0. So all this is doing is this is telling Ruby that I have a variable. I want to have a variable that I want to be able to access. It's going to be called call count, and I'm initializing it to 0. So effectively, what Ruby's going to do is it's going to look at that and go, cool, that's a variable, new variable, and it's a 0. So I'm going to infer that that's just an integer. So it'll set up in the background. It sets up so Ruby does have types and classes, but it's very flexible as to how it assigns them, and it's very flexible about how you can switch between them. But if I did something else later on down here, so if I was to go like call count and I said that equals a string, that's not going to complain about that. It'll just override what was in it, and that's it. It's done, and it doesn't really care. So in the background, there's a lot though that has to go on with like memory management and all that sort of stuff to handle that kind of behavior. And that has its own overhead, right? So the interpreted part of this has to be able to, figure out these things and, assign memory and stuff like that, or tell it how to assign memory. But then it also has to be able to know that it needs to swap something out, or it needs to be able to change memory. And then this is also different. Like, again, I don't want to get too deep into it, but, we have the difference between storing stuff on stacks and storing stuff on heaps and stuff like that. And, you've got a lot of, things need to move around. So it's not necessarily a simple thing to do, and it's not necessarily a performant thing to do to just take a block of memory and just go, throw that away and reassign memory and stuff like that at will. That's going to always incur some sort of performance cost. So that's just an example, something there for type of stuff. Excuse me. So if we were to look at something equivalent in Rust, also, sorry, you'll notice that because of this, because we don't have to worry things about types, we don't have to worry about like passing references around to things like that. So if you've done much programming in something like Java or C# or something like that, or even C++, more basic stuff, you'll know that there's like a difference between passing pointers around and passing references around and stuff like that. And a lot of like these kind of very high level programming languages basically abstract all that kind of stuff completely away from you, so you don't have to think about it. But it's not for free, right? These concepts still exist technically, but it's not for free. It's just taken care of for you, so you don't have to worry about it, but it still incurs some sort of cost. You're paying for it in some way. So with that in mind, let's have a look at like some Rust code. So Rust code, very different. Immediately you can see that it kind of looks a bit more verbose straight away. So if you have a look down here, this basic piece of code, this basically just parses arguments that I'm passing in from the command line. And you'll see that already I have some extra syntax in here when I'm defining a variable. So in this case, I've defined a variable and I've said that it's called step. Let keyword is just basically to define the variable. But then we also have this mute thing, which is a little bit different again. So by default, in our Ruby code, everything is pretty much mutable when you define something, unless you define it as a constant. It's going to be mutable, which means you can change its value. You can operate on its value. In Rust, that's not the case. You have to define that something is mutable. So you can define something, but then you won't be able to change its value unless you define it as mutable specifically. So this is just another thing where Rust is being a little bit more deliberate about what you're going to do and how you're going to define stuff. And this all has impacts on how it is handled in memory and stuff like that in the background. So in this case, you also then have to tell this variable what its type is. Excuse me. So a variable has to have a type. In this case, Rust has inferred what the type is here. So I've just set it to a 1. And basically it's done the same thing that Ruby did before. It inferred what that type was going to be. In this case, it says it's a U size, unsigned size thing. And then down here, same thing. It can have like, I set it to 0, and it's decided that that's going to be an I32, which is a 32-bit integer number. So that's what min is. So if I go down here, and now I try and like do something with min. So if I say min, and now I say it's equals to, a string, give it a semicolon. This is given out to me now. So it says mismatch types. So it knows that min is supposed to be an integer. And now I'm trying to pass in like a string to it. It knows that that can't happen. Or it's not supposed to be able to happen. So it's a bit more deliberate. You have to be deliberate about what you're doing. And this is just like part of the guardrails that you'll get when you're using a strongly typed language like this. Like in Ruby, you can accidentally change a type without noticing it. And now I'm not saying like, it's going to be an integer and then all of a sudden you start passing strings to it, but it can be a bit more subtle than that. Like you could have a list of integer numbers and then you do some operation and it actually returns a float. And now all of a sudden your number system is not integers anymore. Now it's floats, which could have a subtle, but knock on impact on something that you do. Some calculation you need to do further down the line could break something. And it's a little bit more subtle. You wouldn't necessarily notice it. Whereas in Rust, you will notice it straight away because the compiler won't even let this code compile if it has this type of error in it. So it'll know where this error comes up. This is another difference then between Ruby and Rust. So in Ruby, a lot of the trade-offs with this freedom means that you have to deal with runtime errors far more often. So the ideal in Rust is that your compiler and your type system and everything takes care of most of the stuff that can lead to runtime errors. So that if you do get a runtime error, it's probably something to do with like, some bad data or something like that that doesn't obey the structure that you've set out. It's very unlikely that the code is going to error at runtime if everything is as it's expected to be. Whereas with Ruby, because there's none of these type of protections, it's very, very easy to just have code that will error in at runtime, and that's almost kind of an expected thing, really, that you're going to have to deal with. So again, another difference between how you kind of think about how this code executes and what it does. So I'll give you another good example of some subtle differences. Also a similarity. So in Ruby, I absolutely love to use hashes. So this is a hash in Ruby. This is what I've called input here. So this syntax basically is how you make a hash map in Ruby. Hashes are incredibly powerful. You can basically use them to store any kind of data that you want, and they're very, very flexible. I use them all the time, and they have like, the keys. You basically store key value pairs, but the values can be anything you want. They can also be other hashes in and of themselves, which means you can make these huge nested data structures. And accessing them is extremely fast because it's a hash map. So the key is accessed with constant time complexity, basically. So if I have a key, so if I say like input, A equals 5, then I can like go say like puts input A, and that'll write 5 out to the terminal. And it doesn't matter how many things are in input, that will always take the same amount of time to do that, because the access is constant time. So yeah, extremely powerful data structure. Hash maps, they're great. But you notice there, I was just able to just start arbitrarily typing, and I can change the types. I don't have to worry. I could have like loads of different types of keys. Doesn't matter. Ruby doesn't care. You'd have to check those types when you were like pulling values from them, but as long as you know, it's not really too much of a problem. In Rust, you can also have hash maps. So I'll just go to somewhere where I use one. Let's say down here. Yeah, so here's a definition of a hash map here. So you'll see straight away, it's a little bit more verbose. I've had to specify that it's a hash map. Sorry. And I've had to say the key is a 32-bit integer, and the value is a vector of strings, which is basically just like an array of strings. So that's all that can be stored in this. You can't store anything else. It has the same advantages. Accessing this is accessing the values in this is the same. Accessing the values, yes, by the key is still constant time, so it's very efficient. But I can't arbitrarily store other things in this like you can with a Ruby hash. So it's a little bit less easy to use. But one of the things as well that you add with protection, I'm trying to see where I do this. So basically, I'll show it in kind of Ruby land first. So yeah, in Ruby land, if I wanted to access that key that I did, so say something like, so I have my input and I said A is a key and I said it has a value of 5, so that's fine. But then if I want to try and retrieve a value, so say like B, which I haven't set B, so when I do like puts B, what that will do in Ruby's going to look at the keys. You're just going to look for B in the key map. It's not going to be there, and it's just going to shoulder shrug. That's it, and it'll just return like nil. So this will just like write out onto the screen nil or whatever. That's it. It doesn't care. It doesn't need to care because it goes, doesn't exist, and just ignores it. Rust, on the other hand, has a slightly different approach to that. So for Rust, if you want to access a key, you have to know that it exists, and if it doesn't exist, you will actually get a runtime error. And the way that happens, so say down here, I have this code which is like, I say points. I want to know, does points contain the key, which is the value. If that happens, that's fine. I say, okay, that's good. So then I go down and then I go to the points and I access the key directly, and that gives me the answer. But I have another way I can access it. So I can go something like points dot, let's see, get. So I have get, so I pass in my ampersand key, and yeah, so what it returns then, so I'll say like let thing equal this. So what thing returns here is this option type. So what's an option type? So this is a thing that exists in Rust. It's kind of similar to something that a type of thing that exists in Go as well. Basically, option is, so if I arbitrarily take a hash map and I go to try and pull a key out of it, I have no idea if there's actually that key in this list at all, unless I've checked it. So if I just go without checking and just go to try and access it, there's two things that can happen. There's two sort of states. One is it returns the value. The other is it doesn't return the value. So you end up with this option type being returned back, which can be none, or it can be something of that type T. So that's the option. We have then this syntax in, so I'll say let value equal, and so if I go thing dot unwrap. So unwrap is a function built into Rust, which takes an option type and it attempts to extract the value that's wrapped up in the sum thing of that. So we know that it's an I32 because that's what this is a hash map of. It's a string, an I32. So that'll return some value. But this line of code will cause a runtime error, which in Rust is called a panic. And so this will panic effectively if the key doesn't exist. And that's a very deliberate thing in the language. So you'll see a whole bunch of different operations that can be done where there's an option gets returned with none or some, and if you try to unwrap it, you get a panic, and then you can deal with that in some way or another. Or you might just want the application to shut down. So for this instance, that kind of makes sense. If I'm accessing a hash and it doesn't have a value, I probably just want that to die. And yeah, there's other things as well. Like if you do some file reading, so I do some file reading here. Where is it? Yeah, so this is actually a file writer thing. And you see here, we've got like unwrap stuff because if you wanted to access a file system, you don't actually know if a file exists, or say, especially with reading. Actually, is that down here? Yeah, this is here. So if you want to return something, you don't know whether you've actually got so you don't know if the file system actually exists. So you want to it'll return something like an option, and you have to then check what that is. And if the file doesn't exist, you're going to probably error out, because you might decide in your application that no, that file always needs to exist, something like that. Anyway, that's kind of, I don't really know why I went through all of that. This is just stuff that's been occurring to me. It kind of, this is very train of thought. I'm sorry, this isn't super well thought out, but there is kind of a point to this. I think I'm trying to point out the differences between Ruby and Rust, and some of the key things that I found going through it. Seems like we may not get to actually talk about the marching squares algorithm fully in this video, but anyway, let's run some code here and have a look at the other reason why I wanted to look at this. So all the stuff that I mentioned, a lot of it is, so Rust is very deliberate about its memory management and about how it kind of structures itself. And one of the big things for that is just efficiency. It wants to be fast at doing this stuff, and that's why you would write your code in Rust. So we would hope that if we wrote our application, if we took the same logic, the same code that we had basically in Ruby, and we implemented it more or less doing the same thing in Rust, we would hope that the Rust code should be faster. So let's try that and see. So these two algorithms that we have here, they basically do the same thing. Now, this is a little bit more straightforward. It's just one line, one code, 200 lines of code, does a lot of stuff. I went very overboard with this Rust code, and it's like got files, different files, and split up structurally, which was deliberate because I wanted to play around with actually structuring a Rust application and stuff like that. So it's a bit more verbose, but effectively the bones of the algorithm are the same. So let's run them and see what we get. So if we run our Ruby code first, we shall see. So ran pretty fast. I'll zoom that in for you guys so you can see better. So that ran in 4.14 milliseconds. Generated a few different paths. I'll show you what that means in a second. And then if I run the same algorithm on the same data with the Rust code, so that ran a bit quicker. Ran in just under 2 milliseconds. So it's a little bit faster, about twice as fast. Now, the data set that this is working with is really, really small. So I just wanted to show you this one because it's just easy to see that they're doing basically the same thing. But I've run on much bigger data sets, and on average, when I'm running this, I'm getting between about 3 and 8 times the performance, depending on like the size of the data sets. So for the bigger data sets, Rust performs far better. Excuse me. For smaller data sets, Ruby is running just fine for them. Really doesn't really make much of a difference, but you can see even for this very small data set, Rust is eking out a little bit extra performance there. So just to show you what that does, so that is outputting these files. These are NC files, G-code files basically. So these are specifically what this whole application does is it takes like a raster data and it converts it into, it runs the marching squares algorithm on it, and then takes the outputs of that and generates a G-code file, which will let me engrave it with my CNC machine. Full video below on that whole process coming up with that. But yeah, so if I take this piece of this code here, so I already put it in here, but I copy and paste it in again and then plot that out, and there's that's our shape that we have generated from the G code, and then this is the other one. So if I go to my Ruby code, grab the program, see the units are different. That was just that's a scaling thing, specific implementation thing, which you don't have to worry too much about. It doesn't change the algorithm at all. But there we go. We see we have these two shapes and they're the same. And there's the same number of lines that make them up basically. And the yellow lines are like where the engraving bit lifts up to move to the next path that it's going to engrave. So those are different. And they're different because the algorithms start at kind of arbitrary points. So between any two runs, they might not be the same. Not necessarily deterministic. So between the Ruby and the Rust code, they actually end up being different, but the actual shapes that it's drawing and the amount of strokes that it takes to draw that is the same. So we see that down here, it's 134 individual little strokes. So that's like, I can show you that if I turn on a view here. Toolpath points. Yeah, so between each point is a stroke, and we see we got 134 for both of them, and then each path is basically like from here, going all the way around. So back to the start again. That's a path, and this has generated 7 paths, and they both have generated 7 paths. So they give you the same answer for the same data, and that's it. So I just looked at the clock and realized how long I've been talking for. Didn't necessarily intend to talk for this long, but anyway, this has been my experience. This is what I've been working on for the last couple of weeks, on and off. I also started a new job this month, so I've been extremely busy, but when I've had some time, this is the stuff I've been working on and thinking about. So what's next? If you guys are interested, leave a comment down below, and I'll make a specific video where maybe I'll look at the Rust code and we'll look at the marching squares algorithm, how it's been implemented, because it's interesting, and I think I implemented it in a reasonably good way. Nothing crazy, it's just trying to get the job done, really, for what I wanted. But if anyone's specifically interested in that, I can do a video on that. Leave a comment down below. But anyway, next steps with this. What do I want to do? I want to keep learning Rust anyway, because I'm having a really fun time doing it, and I really enjoyed writing in that language. So I want to do more. What I will be doing, so this code, by the way, this app is called RustCam, Computer-Aided Manufacturing, which should be a clue that I want to do more with it than just this contour plot thing. So within it, there's this contour plots folder, and within the configurations in here, I've got this set out that there's a binary that'll output that app that you can run, but there's also this library section which I haven't done anything with. So part of what this app does, it has this G-code generator thing, which is this is really dumb. It's nearly copy and pasted almost identically from the Ruby code, which you can see it down here. It's nearly the same. It looks almost identical between the two. But I want to make something kind of smart and modular that can allow me to generate G-code for any kind of arbitrary algorithmic type thing that I want to do. I especially want to use this to maybe configure a pen plotter and do some generative art stuff, which I've done in the past, but now I've done it. I really realized that I had written the same code over and over again to generate this G-code before, and that's not a very efficient way to do it. So this library, RustCam, is going to be a general set of tools for generating G-code. And inside it, I'm going to write a bunch of binaries. So this contour plots is just one of those binaries that I'm going to use. And then I'm also going to have other ones. So I recently made ones that would generate Spotify code, scanning things that I could engrave with my CNC. So I'm going to implement that in this Rust thing. And then I want to try and use this in the future to do other sort of generative art stuff using Rust, which I think would be cool. So that's all stuff that I want to do. It will happen. But, just depends on when I get time to work on it and stuff like that. So that is kind of the next thing I want to do. Because I have this now, I want to maybe implement one of my other things, maybe the Spotify codes one, because it's a relatively easy thing to do. And then I'm going to flesh out this library where I'm going to make the custom G-code generation stuff and make some stuff to configure different machines. At the moment, I only have one CNC machine, so I can just make it to work with my machine, but I want to make it a bit more configurable, so it's kind of more generic. And that's all stuff to do, and I want to do it all in Rust because I want to really immerse myself in it. So yeah, that's where we're at. That's what we're doing. I have some other Rust projects planned. I'm probably going to make a playlist of all the videos I might do about Rust projects. And yeah, that's it. So I hope you guys enjoyed this. Hope you got something from it. It's pretty niche and abstract. And also, I'm not sure if I flipped wildly between being really basic about things and going super deep about other things. A lot of this was just off the top of my head. So if you guys like this format, please let me know in the comments, because I enjoy this kind of stuff. I like talking about the code and talking about my thought process around things. And if you guys would like to see more of this kind of stuff, please let me know, because I enjoy making this stuff. So I think we'll leave it there for today. I apologize for the length of this video. I don't think I've made a 35 odd minute long video in a while, But yeah, if you managed to watch this long, really appreciate it. Yeah, so let me know what you think. You can find the link to this code in the description. It's a public GitHub repository. So yeah, download it, play with it, have a look. And if you fancy learning some Rust, I recommend it because it's been really fun for me so far. So anyway, we'll leave it there, guys. Thanks for watching, and I will see you in the next one. Bye-bye.